Your whole life, you've been using either Celsius or Fahrenheit to measure temperature. But now you've opened your chemistry textbook and seen something called Kelvins. And you have questions. Particularly, what even is a Kelvin? Well, let's answer that question. First things first, we need to look at a graph that plots volume against temperature. This graph in particular shows the relationship that is known as Charles's law. Basically, what Charles's law is that within a given sample of gas, as the temperature increases, so across the x-axis, as temperature increases, the y value, so volume, will also increase linearly, right? This is a linear relationship. So as temperature increases across the x, volume also increases across the y. Now, if you want a way to remember this, and personally this is how I remember it, you can think of it as from the perspective of a basketball. Now, I don't know how many of you guys play basketball, but if you leave a basketball out on a very cold day, it becomes deflated. The volume of the basketball shrinks, right? And you can think of it the other way around. So if it were a warmer day, if you put it outside, the volume would increase. And this happens when you put the basketball on the porch. Not a recommendation at all. But for the purposes of science, I think it really is a good example. Now, this relates to Kelvins because you can extrapolate this graph to show where Kelvins come from. And extrapolate is just a really fancy way of saying, oh, I'm going to extend this line. So let's extend that line. So I'm going to put dotted lines out here to extend that line, right, as much as possible. And I'm also going to extend the x-axis of this graph. Remember, the x-axis of this graph is Celsius, our standard unit of measurement. Okay? And what you can notice here is that these 2 points, these 2 lines that I drew out over here, intersect at this x-intercept here. And what the value over here is negative 273.15 degrees Celsius. Okay? This is also referred to as absolute zero. And that's a very cool term for a very cool topic. And absolute zero refers to the temperature in which particles stop moving. What that means is that the volume is essentially going to be zero, right? And the reason why absolute zero is significant to our understanding of what Kelvins are is because the Kelvin scale starts at absolute zero. So 0 Kelvins is right over here. Right, it's all the way over here on the graph of Celsius. It's at negative 273.15 degrees Celsius. And the reason for this is because Kelvins, they measure kinetic energy. That's the best way to think about it. At 0 Kelvins, there is no kinetic energy. There's no movement at all within particles. And as Kelvins increase, kinetic energy also increases. All right, so that's the relationship there. Now, what's really important to understand here is that Celsius and Kelvin, they're on the same scale in a way. They're just shifted over, right? Remember how Celsius is here? The 0 point of Kelvin is just negative 273.15 over to the left. That's why the conversion between Celsius and Kelvins is so straightforward. 0 degrees Celsius is going to be equal to 273.15 Kelvins. Because the graph is shifted over that much when you extrapolate it and you find the absolute zero. All right. So hopefully that made sense. In this video, we looked at what a Kelvin is. If you like this video, click the like button, subscribe to the channel, and I hope to see you guys in future videos.